Whether drilling on land or offshore, the major elements of a drill rig are the same. There's a tower structure with a derrick and a steel pulley system for lowering and raising long strings of drilling pipe. There's a drill bit on the end of that pipe and a motor for turning the pipe and thus the drill bit so that it chews through the rock by breaking it up into little pieces. There's also a system for circulating water and mud down through the drill string, out the drill bit, and back up the borehole. Mud moving through this system serves three purposes. It lubricates the bit, it entrains the rock fragments cut by the bit and carries them to the surface, allowing the bit to cut downward into fresh rock. And the mud acts as a heavyweight barrier, preventing fluids under high pressure in the rock from escaping into the borehole and blowing out the top of the well. In offshore drilling, the first step is to move the rig to the drill site and secure it in position. In relatively shallow water, the drill rig will be secured on top of a superstructure whose base sits on or penetrates the seafloor. But in deeper water, some type of tethering system must be used to hold the rig in place. A variety of rigs have been designed for this purpose, with the size and complexity of the rigs increasing with increasing water depth. When drilling on land, the drill site must first be prepared. This includes leveling out an area big enough to contain the drill rig, supporting equipment, and often a man-made pond for holding the mud that will be circulated through the well. Once the drill site is ready, a wide-mouth pipe, at least tens, sometimes hundreds of feet long, is installed where the well will be drilled. Known as conductor casing, this shallow-most length of pipe prevents the borehole from caving in at the surface and is the topmost conduit for fluids produced from the well. After the conductor casing is installed, the drill rig is erected and supporting infrastructure is installed, including housing for the drilling crew. These individuals will work 24 hours a day, 7 days a week while the well is being drilled, which, depending on the depth and difficulty of the drilling through the subsurface, can take up to several months. During drilling operations, the drill crew will repeatedly connect 30 to 90-foot sections of drill pipe to create a continuous string of pipe that lengthens as the drill bit at the bottom of all that pipe cuts its way deeper into the subsurface. The first stage of drilling is to drill below the local fresh water zone and seal off the well so that nothing passing through the well can escape and contaminate the freshwater zone. This part of the borehole is sealed by what is known as surface casing. The surface casing is steel pipe that is slightly smaller in diameter than the conductor casing and thus can be telescoped down through it. The surface casing is fixed in place with cement. Cement is ushered out of a special cement shoe attached at the bottom of the surface casing. The shoe allows cement to flow out of the casing but not back up into it. As the extruded cement is forced up the outside wall of the casing and fills the space between the casing and the borehole wall, it not only fixes the casing in place, but ideally seals off any way for oil and gas to escape to the surface along the outside of the well casing. At this point, a blowout preventer is installed on top of the conductor and surface casing assembly. This apparatus is a set of valve systems designed to seal off the top of the well, monitor and control pressures inside the well, and in an emergency, immediately and automatically shut off any uncontrolled flow from the well. With these freshwater and blowout safety measures in place, drilling down to the oil and gas reservoir commences. A drill bit with a smaller diameter than the surface casing is used to drill through the cement shoe at the bottom of the casing and extend the borehole deeper. During the drilling, mud continuously circulates through the drill string and back up out the borehole, carrying with it the rock fragments cut by the drill bit. The driller uses these rock fragments, known as cuttings, to help determine how far the drill bit is from the target reservoir. As the drill bit approaches the target reservoir, it may be turned from drilling vertically. This turning is accomplished with a special drill bit assembly that communicates the position of the bit and allows the driller to steer it. Using such directional drilling, a driller can enter into a target reservoir layer that is relatively thin and drill a borehole through the layer for lengths of up to a mile or more. Once the planned for length of the borehole has been reached, the bit and the drill string are removed. A third and even narrower type of casing, known as production casing, is now cemented in place along the entire length of the borehole. Note that the end of the well is also cemented and thus sealed off. At this point, the well is completely isolated from the surrounding rock by multiple telescoping layers of steel casing which themselves are encased in cement. No fluids can flow into the well or out of the well. The final step is to create holes through that part of the casing located within the target reservoir rock. A tool known as a perforating gun is positioned at the end of the production casing. It fires off a set of explosive cartridges that shoot holes through the production casing and cement into the target reservoir. If the reservoir contains oil and/or gas and is porous and permeable, this may be all that's needed to get the well producing. Fluids in the reservoir will be under high pressure and they will quickly move into the low pressure well through the perforation holes. The perforating gun will be moved back along the well, creating a series of holes through the casing where it penetrates the target reservoir so as to maximize production. It may be, however, that even though the reservoir is porous and contains oil and/or gas, the rock has poor permeability and little of that oil or gas that the reservoir rock contains flows into the well. In this instance, production will be stimulated by increasing the rock's permeability through hydraulic fracturing or fracking. The drill rig is removed and a mobile fracking system is set up at the well site. The initial part of the fracking system is a water supply and a set of storage tanks. Water from the latter is directed into a mixer where sand and chemicals are added. The chemicals are included for a variety of purposes. The primary one is to increase the viscosity of the water so that it carries the sand grains along with it more efficiently. The resulting mixture, which is about 90% water and 9.5% sand and about 0.5% chemicals, is then pressurized and injected down the borehole. The mixture travels through the production casing to the perforation holes which lead into the reservoir rock. Pressures on the mixture are increased until it hydraulically fractures the reservoir rock. During this stage of the production process, the sand grains are carried into the fractures as part of the mixture. Pressures in the well are then reduced and the fluid part of the fracking mixture flows back towards the well. The sand grains, however, remain stuck in the fractures, wedging them open to provide highly permeable pathways for the oil and gas in the reservoir to now escape into the well. Fracking is done in sections. Each frac section is sealed off and the next section of the well is perforated and fracked. The process is repeated for the entire length of the well through the target reservoir so that production is maximized. This combination of directional drilling and fracking has revolutionized the oil and gas industry by opening up oil and gas production from low permeability reservoirs such as shales. Using these technologies, a single well can now drill and produce a reservoir area that beforehand would have required up to 30 vertical wells and it would have been prohibitively costly. Once a well has been completed and is producing oil and gas, a production unit is placed above the well. Offshore, this may be a large production platform that can also be used to drill additional wells. Alternatively, the offshore production unit may be a subsea facility which allows continuous production even during major storms when sea surface facilities need to be evacuated. On land, very little equipment is needed to operate a producing well. If it's a gas well, it will be capped by a set of valves known as a Christmas tree that controls the flow of gas out of the well. And if it's an oil well, it will be capped by a pump jack or rocking horse when the pressure in the reservoir is not enough to drive the oil up out of the well. Production from the well will be directed into a heating unit where liquids will be separated from gases. The liquids will then be further separated into hydrocarbons and water. Depending on state regulations, the produced water will either be pumped back deep underground or treated and released at the surface. The liquid hydrocarbons, such as crude oil, will be sold and trucked away to an oil refinery. And the gas will be piped on to a natural gas processing plant. Eventually, production from the well will decline to the point that it is no longer economic to operate. At this point, the well will be plugged and abandoned, and the well site will be remediated. If the remediation is done properly, there will be little evidence of the oil and gas well, that the oil and gas well was ever there.